right now, so it's not silent anymore. There we go. All right. Besides that question, are there any additional questions about the homework assignment? Yep.
What if we set the quotient and the remainder to the divisor to 0?
Say that again?
What if we set the remainder and the quotient is 2 if the divisor is 0?
You already told the divisor cannot be 0, so you don't have to.
So even in your test cases,
in my test cases, I will explicitly make sure that the divisor cannot be 0. So I gave you the restrictions, so you can be sure that won't happen. All right. The system is doing something. I just recently uploaded my new ISO file, so this is kind of like a new distribution, updated stuff. All right, so let's go ahead and take a look at the homework assignment. Okay, so we are on control structure right now, and the homework assignment that you're dealing with is called divide. Okay, so what I want to do is I just want to show you how you can debug your program and actually basically how my script works when I do auto grading. So the first thing, this is important because there are a few cases where people kind of miss points because of this. When you submit your homework assignment, it is very important that it is created using this command, and the file name has to be divide done with uppercase D for the done .tar.gz. Okay, it's because if the file name is not 100% correct, my script is not going to pick it up. Okay, so this is the most important part. It's kind of like sending your tax return to the IRS. The IRS does not care whether you get everything done, and everything is done correctly. If you send it to the wrong address, the IRS will say, hey, you did not, turn in your tax return on time. Okay, it's the same thing here. Okay, so you just have to make sure that you follow these instructions. All right. Second thing is do not make changes to the file except for the section where you're supposed to write your program. Okay, because if you change the labels, okay, the stuff that has a colon after that, my script won't be able to grade it either. So don't change anything that you're not supposed to. Just so that way I can use the script, use my script to do it. All right. So I have my file downloaded here. So let's look at all the tar.gz files. And obviously I have quite a few. I need to clean this up a little bit. But the one that we are dealing with is called divide. So the command tar xzvf divide.tar.gz will decompress the file. We did this last time. And today my focus is how do I debug this program, because I only have one test case here where the dividend is 215 and the divisor is 34. Okay, so if you want to give your code some actual test, you can change this to something else. So what I'll do is I'm going to change this program so I will have the solution. And yes, I am typing a solution here, but this is a solution that you cannot use. Okay, because this is the solution. Okay, quotient is just dividend divided by divisor, and remainder is dividend mod divisor. Okay, that's my solution. Obviously, if I were to turn this in as a student, I would receive 0 points for this entire homework assignment because I'm using the operators that is explicitly prohibited in the homework assignment. All right, but for the illustration of the concept, this will do just fine. Okay, are there any questions at this point about this program? So your code has to be after the start here label, and it has to be before the check here label. The two labels cannot disappear in the source code. Okay, if they disappear, my script is not going to work. Are there any questions? Okay, if there are no questions, we'll go ahead and take a look at the debug process. Okay, how do you test your code? So we'll do a G++. Remember -C the dash G is important because if you do not do a dash G, GDB won't be able to illustrate, won't be able to show you the source code corresponding to the execution of your code. Okay, dash 1 all is useful if you want to kind of have the compiler to kind of give you some warnings. So in this case, it complains about quotient is set but not used. That's okay. Remainder, same thing. Start here and check here are defined but not used. So in other words, I don't have any go-tos into those labels. Those are all okay, not a problem. So now we'll go ahead and get into the GDB. Oh, wait, I forgot one thing. I have to link the program to the executable, and then we can now GDB main. All right, so the first thing is you have to learn how to set breakpoints. So do a B for breakpoint. Now this time, instead of line numbers, I can now rely on the function name and the label. Do you see how I do not need to use line numbers? Because because there are two labels defined in main already. If you want to stop at a particular label, you will have to say B, which is breakpoint, main, which is the function containing the label, a colon, and then the name of the label. Okay, so this can come in pretty handy. Next thing I do is to simply run the program. By the time I get here, I would do a set var. Okay, so I can now actually give it a test case. Set var dividend is, I don't know, like 47, and set var divisor to let's try 23. Odd number, prime numbers are fun to play with, and just to continue execution at full speed. Now you may or may not want to do a continue. Okay, that depends on whether you are debugging the logic of your program, or you feel confident that your logic is right already, and you just want to run all the way to the other label and check the result and see whether it is correct or not. Okay, so I'm fairly confident that I'm doing this right. So I continue. Now it stops on line 18, which means the code is done. So now I can say print quotient is 2, print remainder, it's 1. So 2 times 23 is 46, 46 plus 1 is 47. So this is indeed the correct answer. Okay. Now, doing all this stuff, repeatedly can be tedious, and many of you probably do not want to do something that tedious. So what do? Well, then you do things like what I do. I automate. Okay. So you can automate this whole process. I can show you how to do that as well, because I think it will be very helpful to be able to do this. Okay, so if you want to automate this whole thing, you just have to create a new file, and I'll just call this divide.gdb. Okay, the extension is not important. I only name it with a .gdb just so that it will remind me that it contains GDB commands. So this is kind of like a script. So I'm using a script to test a particular program. All right, so in the script here, you can just type whatever command that I used earlier. In other words, I will first set the breakpoint, main colon, start here, B, main colon, check here. Okay. In other words, whatever I type in GDB, I can just put it into this file. Now, the scripting of GDB can do a lot more, but at this point, I'll just do some really simple stuff. Okay. So remember, next time I have to do the run. Okay, this is the reason why it won't let you change the variables, because until you actually run and go up to a certain breakpoint, the local variables do not exist. Okay, in fact, that is a main topic of today's lecture. Is what are local variables? When do they start to exist? Okay, so run, and it will hit the first breakpoint. At that point, we do a set var, and I think we set dividend to a particular value. So let's say 57 in this case, and divisor set it to I don't know, 16. Okay, and then we continue execution. C. By the time it stops again, we should be at the label check here, which means your code is completed. So at that point, you can now, there are several options here. You can say print, and you can just print. Let's see, we are printing the quotient. And you can print the remainder. Okay. And let's just say this is all that we want to do, so you can do a queue or quit at the end. Okay, so this is only one single test case. I'll show you how to do multiple test cases and also how to kind of make it easier to tell whether your program did it correctly or not. But for the time being, we'll just do it like this. We'll test it, see if it works. Okay. So to use that file, I know I just kind of got out of the editor real fast, but since it's being recorded, so the details is not the important part. The important part is why we are doing this and what it is. Okay, not how. Oh, tell me again, why are we doing this? Sorry? So it's not tedious. So you can actually make a whole bunch of test cases, and you can, every single time you make any change to your source code, you can run it through all the test cases again. So the more test cases you can run through over and over again, the more confident you will be about the correctness of your algorithm. Okay? So this way, you're systematically checking the program. You're not just spot checking. Okay? All right. So getting back to here, GDB main, just like before. Now we use this less than symbol, which has a very specific meaning. Okay. So the less than symbol on the command line in any shell, including the Windows DOS shell, has a special meaning. It is called redirection. In other words, in this case, the content specified in the file divide.gdb is fed into GDB as if I typed those commands myself. Is that part okay? So the redirection symbol is very helpful because it allows most programs using the command line to be able to be kind of semi-automated. So I just press the enter key and you can see this is the end result here. Now, the first time you see the end result, it looks kind of confusing because all it does is to show you the first number is, let's see here, continue. And it shows one number, it doesn't show the other one. Okay. We set the breakpoints, we set the values. Okay, something is not right. It only prints one particular value. Let me see. Did I name these incorrectly? Remainder looks right to me. I'm just checking the spelling of the variables. Remainder is remainder. That is correct. Okay, so let me just try again. So, there we go. It only prints one number, which is 9. And 9 should be the remainder because there are 3/16. So it didn't print the quotient, or the quotient is printed, but I didn't catch it in the output. Let me just do it one more time. Do you see a 3, which is the remainder? I mean, the quotient? It's missing the quotient. All right, let's do it by hand then. One more time.
Are the GDB labels case sensitive?
Yes.
Okay.
Yep. Everything is sensitive in this class,
Okay.
including the labels, file names, and etc. Okay, so now I can say print quotient. I might have misspelled quotient. Okay, so this is the correct behavior of this program. So now if I look at divide.gdb, quotient, that is correct. Q-U-O-T-I-E-N-T. Q-U-O-T-I-E-N-T, that's correct. Well, I'm just gonna brute force this and make it print twice, so that should, fix the problem. There we go. So you can see that. I think I know why, because in breakpoint 2, it's asking for something to continue execution, which is kind of strange. I don't know why it's asking me that, but at least at this point, I can see the first number is 3, the second number is 9. So it does take a few tries to get it to work, because it's not quite exactly the same thing as typing in the commands yourself. Is that okay? Does everybody kind of get an idea of how to do this? Okay, but one test case is hardly enough. So the question now is, how do you take this one test case and go ahead and turn it into multiple test cases? You just have to copy and paste the lines and change the test cases. So what you do is you copy from the R line, because you have to run the program from the beginning again when you want to test it again. So from this line all the way down to the last line here, just make as many copies as you need. And I'll show you how to do it in VI. You can do it in other editors. I'm just much more familiar to do this in VI. So line 3 to line 9, copy to line 9. So now I have 2 copies of the same code. With the second copy, I can now change it to 157 divided by 26. So now I have 2 test cases. So you can expand the number of test cases, to any number. Okay, it's just that you will have to read the actual output to see whether the output is correct or not. Am I still doing okay so far? Okay. Yep.
I don't know, do I need to ask the user to enter any details?
Say again?
Like to ask the user to enter any details so that at least enter the dividend and then
Nope. Nope. You have to do the whole thing in GDB. There's no input or output with this program. So set var is the only way to actually, feed a value or specify a value to your variables. Okay. Are there any questions about this particular script? No questions? Okay. Yep. Go ahead.
I guess, aside from the application script, what was the command for calling it in GDB?
In GDB? To do what?
I mean, just to run the script.
To run the script? To run GDB with a script, that's the way you do it. You just redirect the file that I just created, the text file that contains all the commands, and you just redirect, which is the less than symbol, to GDB. So when GDB runs, then it's not going to ask you to type anything, because it knows everything now comes from the file. Okay. Any other questions? Other questions? Well, I'll just do this one more time, and you can see that in this case we have 6 and 1 as the result of the second run, okay, which is probably correct. Are there any questions? Yep.
Can you bring that back up?
That one?
The last one. Not that one, but the one that just flashed. Yeah, that one. Thank you.
So this can come in handy not only for this homework assignment, but for most of your homework assignments. Yep.
When you're running your test cases on our homework that we turn in, is it going to test to make sure that those numbers are actually correct, or is it just going to assume that the numbers, that if it gets a number or a whole number, it's going to be right?
No, it will check the numbers to make sure they're correct.
Can you show us how to do that in the script?
Absolutely. Okay, so the question is, how do we know whether those numbers are correct or not, right? So you can actually do that. I'm trying to find out what is the quickest way to do it. There are several ways to do it, okay? The first way to do it is to basically do your own calculation, okay? Now, if you do your own calculation and say, oh, in this case, the quotient is supposed to be 3, then you can say, oh, let's check whether the quotient is 3 or not. If so, then we say correct. If not, we say incorrect. So we are basically using a ternary operator, but this time we apply it to a GDB command. So when you look at this, what does it say? It's a ternary operator. This is the condition. It's either true, which is non-zero, or false, which is 0. It's comparing quotient to 3. If quotient is in fact 3, it will print the second expression, which is just the string correct. If it is not true, it will print the third component, which is incorrect. So this is
we would have to figure out those calculations
Correct.
before we set up this
well,
script.
not exactly. Okay, so if I really want to be like super duper, lazy, I can do that. I leave it up to GDB to figure out what is the actual answer, right? And now I can also do it to this one. Okay, so 57 mod is the same as taking the remainder of a division, so I can now do the same thing. So I can say correct versus incorrect. Okay. But if you really want to be more, verbose, okay, so you can say, this is trying 57 divided by 3. So this way, the following message, which is correct and incorrect, will apply to a particular test case. So you can make this kind of as fancy as you want. If you want to make it fancy, you can definitely go all out, to make it fancy. Or if you want to go for the real basic ones, just print out the values of quotient and remainder. You can do it that way as well. Is that answering your question? Okay, great, excellent. Are there any other questions? Can you guys think of representative test cases for your program? How would you test your program? What kind of test cases are you going to use for this particular program? Are any cases particularly special?
When they're both the same number?
Okay, same number may be special, right? 6 divided by 6 is 1 with a remainder of 0. Okay, using a dividend that is less than the divisor may be tricky too. Okay, is that having the divisor being a particular value, which is 1, can also be tricky, because in that case the dividend will become the quotient. Okay, so you kind of have to think about these special cases to test, and not just in general I want to divide 7 by 2, the quotient should be 3 and the remainder should be 1. Well, that's good. If it works for that test case, it's good, but it's not a particularly tricky test case. So you kind of have to think about all the exceptional cases. It's like, well, this should work, but it's not like a usual division. Okay. Yep.
What happens if you try to divide by 0 with this? Does it just return an error?
Yes, it will basically give you what we call an exception, or it will crash the program basically. Because when you divide something by 0, the instruction that is doing the division is going to crash. But in the homework assignment, you are guaranteed that won't happen, because in this case, it's actually in the text file itself. Let me take a look at main.cpp. So in this case, it's explicitly stated that dividend is going to be at least 0, it won't go negative, and divisor is at least 1. So you're guaranteed that your divisor is not only positive, it is at least 1. Okay. Are there any questions about the homework assignment that's due on Wednesday? Yep.
What does it mean when the compiler says you have a while loop and it says while was not declared to the scope?
Say that again. While.
The error I'm getting says while was not declared in the scope.
Okay, that means while is not beginning a statement. It is being used as a part of an expression. So that means you did not use a semicolon on the line before that. Usually, okay? Not always, but usually. Okay, all right. Any other questions? Well, the question that you asked, in the first place was a very good question to lead into the actual main topic of today's class. Before we do that, let's take a look at where we are in the reading assignments, so that we know, where are we supposed to find this stuff. We are now in libraries and modular programming, where we talk about functions, how to return a value, what are local variables and what are parameters, and just a general description of what is modular programming. I will leave it up to you guys to read this. Forgot to do one thing. I have to unhide this last one. So let me just turn editing on and unhide it, because it's not a quiz. It is another reading material that is kind of interactive. There are only 4 questions. Okay, not a whole lot, just to keep you guys engaged. Okay, so that you can get some feedback of whether you understand the material correctly or not. Okay. So what we're going to do with this one is I'm going to show you some kind of interesting cases where I will use GDB to help me visualize what is going on when we're dealing with these test cases. Okay? All right. So first thing first, let's go back to this particular program, and we'll use GDB main. Okay, same as before. And this time, I'm not even going to bother to go to the label. I'll just put a breakpoint on line 5. Right now, at this point, is the program running? It's not running, okay? So when the program is not running, and I try to take a look at the variables, print dividend, it doesn't work, because it says no symbol dividend in current context, because the current context is empty. There's nothing, okay? The program is not being run at this point. Are we doing okay so far with that concept? Okay? So when we run the program, we'll type R. In particular, we are now in main. Okay? Local variables and parameters are created on a per invocation basis. It's only when a function is called or invoked that the variables and the parameters will exist. Okay? Is main called at this point? Sorry? It is called at the beginning. So the answer. So what is the answer? Yes or no? Yes. Okay. Main is called. So at this point, the variables exist. So we can say print dividend. Now it will have an uninitialized value because the initialization is line 5 itself. But nonetheless, it does exist. It has a uninitialized value of 0. Okay. Are we doing okay so far with this concept? So this is kind of something that we have done quite a few times already, so it's nothing really new. But I want to introduce a few other commands. One is called info locals. Okay, this is actually a part of the reading material, so you don't have to write this down because it's actually in the reading material that I just introduced earlier today. Okay, so info locals will give you an idea of the local variables of this particular subroutine and the values that they have at this point. So it's telling me that I have 4 local variables in scope at this point: dividend, divisor, quotient, and remainder. And it will also show you the values of each variable in base 10, okay, accordingly, which can come in handy, okay? Anything else that we want to take a look here? Yep, go ahead.
I have a question. If you have if you don't set a value to the, like, for instance, quotient doesn't have a value set to it at the beginning of the program. Does it, when you increment it, will it start with a 0, or do you
Nope.
have to establish it?
In this case, if you do not initialize it, it will start with this value, which probably is not what you want. Just remember, in C, C++, and most programming languages based on C, local variables are not initialized. In fact, no variable is initialized. So you always have to make sure that you start with a particular value when you're dealing with variables. It's one of the most common mistakes that people make is not to initialize. But the good thing is the compiler can check for that. In most cases, the compiler can actually tell you and say you're using a variable before it is initialized. So turning on the warning, is very important because it will tell you. Okay. Any other questions at this point? No questions? Okay. If there are no questions about this one, we'll make another program that is kind of more interesting. So we'll go ahead and make this program. Well, I'm just going to use the same program, which is main.cpp. And this time I'll introduce the concept of a subroutine. Okay. So remember, this is where you need to read. Okay, because we have to read about functions, subroutines, how to return a value, local variables and parameters, and also, this is just a concept issue of what is modular programming. Before we move on, let me just ask, how many people are exposed to the concept of subroutines, local variables, and parameters from cisp 300? Should be the majority. I'm hoping it's the majority. No? Yes? Okay, good. All right. So because that's what that class is for, is to talk about these concepts without actually using C++. Okay, so in this class what I'll do is I'm just going to introduce the syntax that is specific to C++. And let me turn on line numbers first, because I can then refer to the line numbers. So just focus on where the cursor is. The rest of the program can just remain the way it is. So let me just kind of give you an empty function here. So from line 1 to line 3, I have a fairly useless function. Okay, in fact, it is a wrong type of way of function, because the int on line 1 specifies the return value type of div. So that means div is the name of a subroutine. It's supposed to return a value. The type of the value is int. Do we have any questions about that at this point? It's a subroutine, it returns a value, the value is returning is guaranteed to be an integer. But that's all we know at this point. It has no parameters, because you can see that on line 1, we have open and close paren with nothing in between. That means the subroutine has no parameters at this point. Is that okay so far? Okay. So now I can go in and make it a little bit more useful. So we'll say, oh, let's take on 2 parameters. We'll take on x and take on y as parameters. So on line 1, inside the parentheses, when I say, let me move the cursor away. When I say int x, it means x is a parameter. It has a type of integer. Y is another parameter. It also has a type of integer. So this is how you declare parameters to a particular function. Yep, go ahead.
So, when you declare a parameter, where does the variable come from? You have to...
It is not a variable. A parameter is not a variable. It is specified by the caller. In other words, whatever code is calling div has to specify the initial values of x and y. Do we have anyone calling div at this point?
No.
Yep, so it's unspecified. Okay.
So, when you call div, would you have to include the x and the y inside a div or outside?
Well, I'll show you the syntax by the time we get there. So right now we are more concerned about the definition of the subroutine itself. Okay. So to make this function even more useful, we'll specify a return value. So we'll just say return x divided by y. Okay. Now it actually does 2 things. On line 3, the return statement actually has 2 purposes. The first thing it does is to compute x divided by y, which is the quotient. Okay, and that will give me a particular value. I'll talk about what the value is going to be used for later on. The second thing it does is to return from the subroutine. In other words, if I have any code after this, like x equals 2 and y equals 3 here, line 4 and line 5 will not execute at all. Definitely guaranteed. In fact, if you turn on warn all, the compiler will complain. It will complain and say that line 4 is unreachable because a return statement stops the execution of the subroutine and it goes back to where it was called to begin with. Are we doing okay so far with this concept? Okay. The behavior of return depends on the programming language, but in C and C++, it does get back as soon as you get to the return statement. Okay. So this is the definition of div. So with that definition, I'm going to delete all of these comments here just so that it doesn't look as cluttered. So now I can say quotient equals div, and I'll give it the actual numbers. So I can give it dividend and divisor. This is how you call a subroutine. You use the name of the subroutine. In this case, it's div. If the subroutine needs parameters, like in this case we have parameter x and parameter y, then you can specify the arguments. Okay, so you can specify any expression that is of integer type as the first parameter. Okay, dividend turns out to be an integer, right? But if I don't want this, okay, I can actually specify something like this. Okay. If I know the dividend is an integer, would that entire expression be an integer as well? If I just, let me just highlight the expression that I'm talking about here.
Yes.
That would still be an integer. So as long as it is a value of integer type, it's okay. Okay? It can be done. Now whether it's the right thing to do or not depends on the context and what your program is supposed to do. Are we doing okay so far at this point? So now I'm going to backtrack a little bit here and talk about, okay, what about the value that is being returned by div? Okay? What is it going to be used for? It will basically take the place of the invocation itself when div is done. In other words, the value of x divided by y, and I'm referring to parameter x and parameter y, that particular value will take the place of the invocation of div, which is the entire right-hand side of this assignment operator. Which means this is going to be the value that it will store back into quotient. Are there any questions about how we define a subroutine and how we call a subroutine? Go ahead.
So defining a subroutine is purely based on what brackets and what brackets you would put in, right? We would initiate div and pretty much make the subroutine just by the brackets initiated.
Okay, the definition of a subroutine starts with a type. Okay, what is the return type of a subroutine? What kind of value does it return? Now, with this part, you can say void if it does not return any value. Okay, followed by the name of the subroutine. In this case, the name is div. Followed by open parenthesis, and inside the parenthesis, you have a list of any number of parameters. In other words, if you don't have any parameters, you can just leave it empty, entirely empty here. Then you have a close parenthesis. And then the compiler would expect a single block statement, which is marked by the open curly brace and the closed curly brace as the actual body of the subroutine. Is that okay?
Yeah, I was just on the page.
Okay, go ahead.
So with subroutines, no matter what order that they happen in, you have to have one before the other. Is there a main routine that commands them all?
In C and C++, the only restriction is the subroutine has to be defined before you use it.
Okay.
So in this case, this is where we use the subroutine div. This is the place where we define the subroutine. So it's okay because we are defining before we use it. There is a way to get around this problem, but I'm not going to talk about it because that's not the focus of today's lecture. Okay, those are all very good questions. Are there any other questions? Okay, no other questions? All right, well, in that case, I'm going to fix this program just so that it does work correctly. Okay, and what we'll do is we'll track down the execution of this program. And the first time we do this, we'll do it only using single stepping. Okay, because I just want to show you what happens when you single step into a subroutine and what happens when you're at the end of the execution of a subroutine. Where is it going to go at the end of the subroutine? In other words, when execution has reached line 3 of this program and you say single step, where is it going to go in the debugger? Okay, and then we'll go back and debug the program again, but this time we'll take a closer look at how do we keep track of that information? How does it know that from line 3 it has to go all the way to line 14 and not to go back to line 13 again? Actually, it does go back to line 13, but we cannot see it. Okay. All right, so we'll go ahead and just save the program as it is now. Compile the program. Link the program. And debug the program. So I'll use list to show at least a portion of the program. We'll put a breakpoint on line 3, okay? Because the rest of the program is fairly known already at this point, not very interesting. So we'll put a breakpoint on line 3, and we'll also put a breakpoint on line 13. Okay. Actually, if I put a breakpoint on line 13, I don't have to put a breakpoint on line 3. So right now I have a breakpoint on line 13. By the time it gets to this line, it will stop. run the program. Sure enough, on line 13, it stopped execution. If I single step, it's going to go into the subroutine. Okay, so single step, it goes right into the subroutine, and now we have parameter x and parameter y. GDB is very nice. Okay, whenever you single step into a subroutine, it will also tell you which subroutine you're single stepping into. In this case, it's div. It will also tell you the value of the parameters. So it's telling me that parameter x has a value of 215, parameter y has a value of 34. Is that matching your expectations? Okay, so far so good. Okay, we have x and y. But the important part here is at this point, x has no affiliation, no relationship whatsoever with dividend. Y also has no relationship whatsoever with divisor, other than they have the same value. Okay. All right. But the biggest question is, if I execute return, which is the only statement in the entire subroutine, where is it going to go? In other words, what is pending on the value that we are returning here? What operation is waiting for? Hey, I'm waiting for a value to finish my own operation. Who is waiting? Quotient equals to, right? The equal operator or the assignment operator on line 13 is pending and just waiting for this. Okay? So when we single step here, in theory, it should go back to line 13 in order to change quotient, to alter quotient's value. But when you actually single step in the debugger, it's not going to show you that it goes back to line 13. It basically says we're done. Well, okay, it goes to line 4, and then single step one more time, it goes to line 14 right away, which means line 13 is now all done. Now, how do you know it's all done? Well, we can always do this, right? Print quotient. And what do you think quotient should be? We are talking about 215 divided by 34. Well, I'm gonna cheat a little bit here. So I'm gonna use GDB to help me figure out what the value is supposed to be and whether it is what it is supposed to be. Okay, did you guys see how I just kind of cheated? Because my arithmetic sucks. So I use GDB to actually tell me what the answer is supposed to be. But the most important part is quotient does have that value at this point. Okay, so is it all good? Okay, single step. And this is the return of main. So if we single step here, it's going to give you some really funky stuff to go on. So don't worry about this. Once you return in main, the rest really doesn't matter. And you can just continue at this point, and it will say it exited normal. Do we have any questions about the process that we just went through? But the question is, how does it know, right? I mean, this is the main question. Let's go back to the main code here, the source code, and try to figure out how does it know that it has to go from here back to here to continue execution. Well, that's because when the compiler compiles, it can tell that div is called on line. Let me show the line numbers. It can tell, the compiler can tell that the line number is on line 13 that has to go back here. But that's not going to fly. That theory is not going to work. Okay? Because if I call this again in some other place, okay, so let's call it here. So I will say quotient, and this time we'll do something that's easier. 255 and 1. Okay? So obviously the second time quotient is going to be changed to 255 because 255 divided by 1 is 255. Okay? But this is not going to be, this will just break that theory that the compiler is the one that put in the information of, hey, when you're done, go back to line 13. Nope, it doesn't work. Because now, the second time I call div, it knows to go back to line 17, or I should say line 16, instead of line 13. So how does it know that, hey, this is the second time I'm called, and we're going to go back there? We talked about this a little bit last time. Does anyone remember? Yep.
Does that actually save, like, basically like an address bit, like kind of thing, like as an actual value?
It returns, it actually saves the the address of where the call was done. Well, okay, let me correct myself.
Yeah,
It saves the address of the location of the instruction right after the call. So when it comes back, it's not going to continue with the call instruction, which is going to be an infinite loop. It's going to continue with whatever is after the call. Okay. All right. So, but I do want to kind of see this work. Okay. So we'll save it. G++ dash C dash G main.cpp. Link it and just run it. This time I'm going to put a breakpoint on just line 3, okay? So the rest of the program does not have a breakpoint. Okay, now we're on line 3. You know how I got here because we already knew the program, and you can tell that x is 215 and y is 34. So this is coming from the first call of div, okay? But if you have a program that has 20,000 lines, and there are 65 places where you call div, how do you know where you got here in the first place? There's a very useful command called bt. Okay, bt stands for backtrack, and it's really, really handy. The first time you look at this, it looks really confusing. It's like, what is happening here? But it's really exceptionally useful because what is showing you right now is we have 2 invocations, okay? 2 function or 2 subroutine invocations. Main is called by the computer operating system, okay? So it's not called by anybody else, but main is the one that is calling div. So it's showing you that we have 2 functions that are invoked active at this point. Div is the current one. I'm in the context of div. Yep.
So when you type in BT, it just brings up whatever values you kind of have as far as...
It brings up the, well, it will automatically show you the parameters of the subroutine call.
Okay, so you don't need to like specify anything when you type in BT, it'll just automatically bring up that list.
Yep, absolutely. But it also tells you the line numbers, okay? It's telling you that on line 13 of main, it called div. And currently we are in div, stopping on line 3 of main.cpp. Now that is a lot of useful information because not only do we know that we are in div, okay, which is great, we also know how we got here. Are we doing okay so far at this point? Sort of? Okay. What if at this point you're interested in the variables in main? In other words, you're not interested in parameter x, parameter y, because we can see quite clearly what they are. So the question is, how do we know about the variables in main at this point? I remember earlier we mentioned that that command called info locals, right? It will show all the local variables. Let's try that. It says there are no local variables. Well, guess what? Div is our current context. It does not have any local variables. So it is actually correct, okay? Because we are not in the context of main, we're actually in the context of div. If you want to, this is not really a good analogy for some really kind of obscure reasons, but if you look at each function or each subroutine as a room, we are now in a room called div. The local variables, dividend, divisor, and so on, they belong to another room called main. So once we got out of the room main, it is still active, that room is still there, back there. I cannot see those variables anymore. So that's why right now I can only see what is in the room called div, and it does not have any local variables. Is that okay so far? What if I insist to know the current values of all the local variables in main? Well, guess what? It does have one command that let you change what we call the frame or the context back to main. It does not get out of div. It simply says, let's go back to the context of main and so that we can examine what is in main. That command is called frame, just by itself, okay? Frame by itself. And you can give it a number. The number that you give to frame will be referring to the pound numbers in BT. So in this case, we can see that main is context number 1. So when you use the command frame, you can say frame 1, which will change the context back to the context of the main subroutine. Now that we're in main as a context, do you think we can see its local variables? Well, let's check it out. Info locals, and we can now see all the local variables in main. Are we doing okay so far? Okay. And if you just type frame all by itself, it will go back to the original. No, it does not. So we have to say frame 0 to go back to the original, the current point of execution. And if you type info locals, then it will say no local variables anymore. In other words, during the execution of a program, when you're at a breakpoint, you can change the context to any subroutine that is active at that point. Okay? Can anyone kind of imagine this can be helpful when you're debugging a program? Because not only do you know where you are, but you can know exactly how you got here in the first place. And not only that, okay, you can go back to any of the previous context or the context that are prior to yours and say, oh, I know we got here from here, but I want to examine the local variables in the context of that caller, and you can do that as well. Is that okay so far? Okay. Well, the rest of this program is not very interesting, except for this part here. We are just about to execute line 3, which is a return x divided by y. How do I know where it's supposed to go back to? Well, BT kind of tells you, right? BT tells you that we are currently on line 3 of main.cpp. When we are done, we're going to go back to line 13, which is in main. But the question is, how does BT know that? It's because every time you call a subroutine, it saves the location of the instruction right next to the call. That's how it knows where to go back to.
Okay, so it's only GDBT? So it's only BT, the command?
No, BT is just a visualization tool. Okay, look at GDB as an X-ray machine or all kinds of radiology machines. Okay, its job is to show you what is inside your body, your bone structure, your internal organs, and stuff like that. But that's it. Okay, this is all the stuff that is actually going on. Without GDB, it's still going on. It's just that you don't see it. GDB allows you to visualize and see everything that is going on as you execute your program. Okay. That was a good question. Yep.
So in this case, it's GDB that's saving that location?
Nope. It's the program itself.
The script that we've written.
The program itself is doing it. Yep. All right. I'm not going to confuse you guys, with info frame, because that's another command. It will show you like a lot of information. So I'm not going to do that. Instead, I'll single step, go back to main, and do a continue. And diff is called a second time. Okay, you remember in diff in the program I called diff a second time. This is the second time. It shows us that x has a value of 255, y has a value of 1. Those two are parameters. Okay. How do we get here? How do we get here? BT shows us that we got here from line 16 of main. Is that okay so far? Okay, just like before. The mysterious part is when we execute line 3, this time it knows not to go back to line 13 to continue execution. It knows that we are supposed to go back to line 17 to continue execution. But that's okay because we already know the mechanism. When you call or invoke a subroutine, it will save the location that it needs to go back to first before getting into the subroutine. So it's a two-step process when you call a subroutine. At the end of the execution of a subroutine, it will do two things as well. The first thing it's going to do is it will retrieve the information that you saved earlier so it knows where it's supposed to go back to. And the second thing it will do is obviously just continue execution at that place. Are we doing okay so far with the mechanism? Sort of? Okay. So I know some of you or some people, well, if I were to take this class the first time, I would be confused at this time. Okay, so I need an analogy. I need a story. Okay, this is the story. So let's say I'm the person who there's a U-Haul truck sitting in the lot at U-Haul. Okay, I'm the first renter of that U-Haul truck. So I got into the truck, I adjusted the mirror, I set all my radio stations and whatnot. Okay, so everything is to my liking because I have a few hours to drive, in the U-Haul truck. Is that okay? So every time you have someone driving the truck, it's one invocation. Is that okay? So let's just say that you come along and you say, I kind of have some stuff to transport as well. So can I sublet the truck from you? Okay, so you're going to sublet the truck from me. That's okay, not a problem. Except I have one little thing about people messing around with my radio stations. All right. So before I loan you the truck, I'm going to ask you to write down all the settings. Okay, so you're going to write down all the radio stations, the seat height, length, the mirror settings and stuff like that. So you will drive it, then you can go ahead and change stuff all you want, right? When you return the truck back to me, right before that, you have to restore all of that stuff. It's the same thing with calling and returning, okay? It's kind of the same mechanism. I'm going to pass the row sheet at this point. I think we got enough time to do the row sheet. Okay, so are there any questions about that analogy? No questions about the analogy? All right. All right, so I'm going to show you another program. This is a really classic example of recursion, but I'm going to use it here. All right, so this is the program, and it's a very typical, example of recursion. The recursion. Let me turn on line numbers because that's important. Okay, so the program itself doesn't look very mysterious. Okay, if you look at main, it has all the same stuff that we have talked about so far. When you look at F, it's also not too mysterious. It has a single conditional statement. In the then branch, we have a return statement. In the else branch, we have another return statement. It's only on line 5 that looks kind of odd because we are in subroutine F, and it's going to call subroutine F. Okay, does anyone feel kind of strange about this? Sort of? Okay, can you tell me why you think it is strange? Okay, because in real life we cannot do this. Okay, in real life, F is kind of not done yet. How can we call F from F? Okay, so what we need to do is not to overthink this. Yes, go ahead. It's being passed around right now. But yes. Okay, so instead of thinking of it, using a normal sense of, oh, we are inside the subroutine, how can we call a subroutine at this point? We want to boil down to exactly what a call does. Okay, what does a call do? There are several things a call has to do. To be exact, there are 3 things this particular call has to do. I'm just going to highlight that particular call here, and I'll name those 3 things that we have to do. First thing is we have to specify the parameter. Okay. Well, since I do have the parameter n, can I compute n minus 1 as a value? Sure, right? I mean, if I have n, I can compute n minus 1, right? Second thing, I have to remember when the subroutine is done, where am I supposed to go back to? Where am I supposed to go back to? Well, I have to go back and finish the product, right? The multiplication. Is that okay? The third thing is go to where the label is. Do we have a function f? Yes, we do. So we'll go to function f and start from the beginning of function f. It's not strange. Are we doing okay so far with that logic? Okay? Because you have to remember, f is really just a label. F is really just a label that corresponds to the very first statement of the entire subroutine. That's all it is. It's just marking the starting point of a subroutine. So when we're inside a subroutine, which is here, and we just say, hey, we want to start from the beginning again, that by itself is not an issue. Does anyone want to see how this program works? Okay, let's go ahead and track this down and see how it works. And we'll do it a few times, okay, and with a different focus each time. So g++ -c -g factorial.cpp. Okay, gdb factorial. All right. So the first time we do this, we just want to see that it does work, okay? So we put a breakpoint on line 19 and just run the program. It's all done. What do you think x should have at this point? What is the factorial of 3? It's 3 times 2 times 1, and that would be 6. Okay. So let's check whether this is 6 or not. Print x. X does have a value of 6. Not a problem. Okay, it actually does work. Okay. Okay, so let's try to figure out one thing here. We'll put a breakpoint on line 18, so this way we can track it down step by step. Put a breakpoint on line 18, start the execution from the very beginning again. Now, this is the first time we get to line 18 with the second execution of this program. If I single step, where am I supposed to go? You'll go into the subroutine f, right? Starting on the first line of subroutine f. Okay? Because whenever we call f, there are 3 things to do. First thing is to specify the parameters. Second thing is to remember where the subroutine is supposed to go back to. In this case, it's supposed to go back to line 18 so we can finish up the assignment operator. And the third thing it's going to do is to continue execution at the subroutine that we are calling. Okay? So when we single step, not very surprisingly, we end up on the very first statement of the subroutine f. Okay? Is that okay so far? Print n equals to 3 at this point, not exactly surprising. BT, it shows that f is called by main on line 18. Is that surprising? No, this is all boring stuff. It's a wonder that you guys are not falling asleep at this point. So when I single step, where is the program going to go? And I can open up a second terminal just to take a look at the program itself. And show you the line numbers. So we are currently here evaluating whether n is greater than 1 or not. N has a value of 3. 3 is greater than 1. Where am I supposed to go? Which line am I supposed to go? The expression of a conditional statement is true. Do we go to the then portion or the else portion? The then portion. And which line would that be? The curly braces are not important. Okay, which return? We have 2 returns. Which line?
5.
Line 5. Okay, so we go back to the debugger and we single step. Oops, single step. We go to line 5. Okay, line 5 is a return statement. But before we return, it has one thing to do. What does it have to do? Well, 2 things it has to do. The first thing it has to do is to call f again and figure out what is f of n minus 1. N has a value of what again? 3, right? 3 minus 1 is 2. So it has to figure out what is f of 2 first. And then it has to figure out what is the product of the result of f of 2 and n, which is 3. Is that making any sense? before the return statement. So that means it has to call f again. Can someone remind me again, what are the 3 things we have to do when we call f? Figure out the parameter, the value of the parameter, right? N is 3, 3 minus 1 is 2, 2 is the value of the parameter. Wait, hold on a second here. Isn't that going to overwrite my own parameter? Because right now, N is 3 to me, from my perspective. So when I call this again, isn't that going to overwrite my own value? Well, we'll defer that question just a little bit. What is the second thing it has to do? It has to remember where to go back to when this invocation is done. So we are supposed to go back to line 5 so you can finish up the multiplication operation. Hold on a second. We already have something remembered going back to line 18 in main when we are done. Isn't this going to overwrite that information? Well, we'll defer that question again, okay? And then the third thing it's going to do is to continue execution in the subroutine that we're calling. Which subroutine are we calling? F, okay? So we'll single step. I'm just kind of evading those 2 important questions for the time being. So now we're back to line 3, which is not surprising. But the most important question is, but what about the parameter values? Because the first invocation has a parameter, or has an argument of a value of 3. This time it has a value of 2. What happened to the other one? That's the first question. And then similarly, we also want to ask the question, before we have to remember to go back to line 18, which is inside the main function. Now that we have to go back to line, what was it again? We have to go back to line 3. Yeah, we have to go back to, no. Line 5. We have to go back to line 5, So what happened to the information that we saved earlier that we have to go back to line 18? Isn't that lost as well? The answer is no. Everything is good. That's because parameters, where you're supposed to go back to, and all local variables are created on a per invocation basis. Not on a per function basis, but on a per invocation basis. Every time a function is called, it will allocate the space and remember those things. Are we doing okay so far with that and now with that concept? Yep, go ahead.
Is there any way to reference that memory? Like if you ever need to say,
Yes.
okay, I need you to go to.
Absolutely. That's why we talked about BT. Okay? So right now, when we show BT, it actually shows, hey, we have 2 invocations of F. Okay? The first one, #2, says we started off with main. Not surprising. On line 18 of main, we called F. Not surprising. The first invocation of F has a parameter value of 3. Okay? Not surprising. But here comes the fun part. On line 5 of factorial.cpp, which is inside F already, we called F again, but this time with a parameter of 2. So all of this information is tracked because it is on a per invocation basis. Parameters are on a per invocation basis. Where you're supposed to go back to is on a per invocation basis. And local variables, we don't have any in this case, is also on a per invocation basis. Yep.
Automatic local variables, are they dynamically allocated in memory?
Yes. In fact, all the local variables, all the parameters, and where you're supposed to go back to, collectively, they are a part of what we call a call frame. And that's why the name frame is used in GDB to refer to, which context are we talking about? Are we doing okay so far with this part here? Okay, so we'll go ahead and single step again. We are currently on line 3 of F. Okay, so if I switch to the display of the code here, we are basically on line 3. It's going to evaluate whether n is greater than 1. What is the value of n at this point in the current context? 2. Very good. Okay, so when we switch back to the debugger, we single step, it will go into the then branch again, which is on line 5, and it will call f again. What are the 3 things that we have to do when we call f? Oh, come on, tag, this is getting really boring. First thing, we specify the value of the parameter. N is 2, 2 minus 1 is 1, so 1 is going to be the value of the parameter to this new invocation of f, which is going to be the 3rd invocation of f, okay? The second thing we have to do is to remember where we're supposed to go back to. We're supposed to go back to line 5 to finish up the multiplication operation. But that's okay, because it is saving this as a new frame. It has no relationship to the earlier frames. It is independent from the earlier frames. The third thing we have to do is to continue execution in f starting from the very beginning. So now we single step, and not very surprisingly, we start from the very beginning again, okay? But this time n has a value of 1. How do I know? Because when you single step into a function call, it actually shows you the value of the parameters, which is really nice. Is 1 greater than 1? No. 1 is greater than 1 is false, so we have to go to the else branch. The else branch is on line 9, okay? So we go to line 9, single step, we continue execution on line 9. It returns 1, which means we are returning a value of 1. That part is not mysterious. 1 is just a constant. Single step. Now we have to close curly brace. Once I single step at this point, it will go back to where we are supposed to continue execution. Oh, I just lost track of where I'm supposed to go back to. What should I do? Backtrack, BT, okay? So when you use BT, it shows you the current context. We are about to execute line 11 inside F. Where we're supposed to go back to is where we came from, which is line 5 of F, so that we can continue with the multiplication. Is that okay? But tag, I'm confused. There are 2 line 5s here because there are 2 invocations from line 5. Are we doing okay so far with these concepts? Yes, go ahead.
At the beginning, the 0x084, is that like the actual address?
Yeah, it's an address, but for now we'll just ignore that. So ignore the mumbo jumbo stuff. Yeah.
Okay.
But the key point is at this point we have 3 invocations of F. Okay? And we can see that the first invocation has an argument of 3, the second one has an argument of 2, and the third one has an argument of 1. We are about to return from the 3rd invocation back to the 2nd invocation. But we know exactly how to do it because every single time we invoke, we remember where it's supposed to go back to. And all of that stuff is created on a per invocation basis. So you can basically do it as many times as you want, as long as you have enough memory to remember all that stuff. Are there any questions at this point? So we'll single step, okay? We'll single step again. This time we'll go back to line 5, but remember line 5 will complete, basically on its own, and we get back to line 11. Unfortunately, we cannot see the return value. There's no easy way to show well, maybe there is. Okay. If you say info frame, it will give you a lot of mumbo jumbo stuff like this, okay? Which is okay, we just have to focus on the stuff that we do understand. It shows you the argument is 2 within this current frame, but it doesn't show you the value that we're returning, unfortunately. There's a way to actually show the value that we are returning. It's a little bit early for this class to understand that part, but I can show you, the value that we are returning. Is if you do an IREAX, it shows you the current return value. It is 2. Is that right? It's 1 times 2. Okay, so this is the right return value. So we single step again, and this time it is okay. If you do a BT, we're now back to the first invocation of F. We just computed 3 times 2, so the return value should be 6 at this point. Let's check that. It really is 6. So when we single step this time, which is the first invocation of F, we go back to main to finish up the assignment operation. At this point, X now has a value of 6. Now it's a good thing that this is all recorded, because I am pretty sure that somebody is going to watch this again. But remember, just don't watch it again. You have to ask yourself those questions. Okay, do I understand the concepts? And I know we're running out of time. Okay, but I just want to bring this up just so that you guys can kind of relate what we learned today with something that you already know. How many people remember Arnold Schwarzenegger in Total Recall? Okay, what was the problem? What is the dilemma? The dilemma is, yep, exactly. So in that case, his memory is not, okay, every time they change his personality, it is quote unquote a invocation, okay? The problem is, in that particular technology, every time there's an invocation, it's not remembering the previous invocation. So he cannot just do a return and back to his old evil self. His good self stuck. There's no way to return because there's no return address to go back to. I'm not sure whether that works or not. Okay, how about this? Star Trek: The Next Generation. Okay, many of you are probably way too young to have watched all of the episodes. How many people have watched at least one or a few? Okay, or too many? Okay, do you guys remember there was one episode where they created the character called Moriarty, the nemesis of Data in the holodeck? Sort of? Maybe? Okay. Do you remember how Moriarty defeated Data? Okay. The holodeck is basically a world created within a world. Okay, so you walk in the door and suddenly, there's a whole new world, that is simulated. So the Moriarty character created a holodeck within the holodeck. So when the crew walked out of the quote-unquote holodeck, they were actually walking into another holodeck that Moriarty has created. But they didn't know, they thought they walked back into reality, but that was actually not reality. They were tricked by Moriarty. Okay, I can see you guys are not really getting it because you have to watch the show. So go to YouTube, find it and watch it. Yes?
Was Inception recursion? Was Inception recursion?
Exception?
Inception.
Inception.
It was like a summer blockbuster like a few years back.
I don't know about that one, sorry. What is it about?
Pretty much people keep diving